It's been a while since I did this. Essentially, a few months ago, I did a talk at work about the Google Big Bench project, and I never actually recorded that talk. So I got the slides together. There's been a few updates since I last worked on the slides, but I think you can get something interesting out of this. So, the problem that was being addressed by Big Bench was we have all these large language models, and they should be able to work on a super wide range of tasks, not just on any one specific goal, but we should be able to even throw brand new tasks at them as well. And the way that AI machine learning world looks at these models is by comparing their scores on common tasks called benchmarks. So this is where the name Big Bench comes from. And this isn't to say that the benchmarks are perfect. This isn't to say that the benchmarks cover every possible thing that needs to be covered. The main thing, though, is that we can use them to compare different models without relying on like one person or the other saying this is the best or I worked really hard on this and it's super cool. Rather, instead, we'll be like, okay, are these things making progress against a specific task? And typically, they get developed by a research team at a big company or research group or university, and you'll hear about them when they go on to archive or other conferences. And then there are a few of them that sort of become like the timeless, like major benchmarks that people keep using and hearing about. Squad and Glue being the more common, older ones that people were familiar with back when people were making different BERT models. But others are definitely falling into obscurity, not because there's anything wrong with them, but because there's so many hundreds or perhaps thousands of tasks out there that, a university group makes something, not every model is going to be run against that task. And some models, like the OpenAI and Google newest releases, aren't even publicly available. So only Google or DeepMind or OpenAI people are going to even test out these models on those benchmarks because they have access. So the concept that came up around this was, what if many of these benchmarks got rolled into one mega benchmark? And Google was sort of in a unique position to do that. And what they promised was, if you write a benchmark that's sort of its own thing, or you've published it somewhere else, but you're rolling it in now, a successful pull request would equal co authorship on their final paper. This is a rather interesting model. It's very different from how those groups were typically working, but it was very appealing to me as somebody who isn't in the academic world because I knew how to do a pull request. So even if I wasn't familiar with that different inside baseball of doing academia, I had a good feeling about sending in a pull request, getting it reviewed, and getting it merged in. In the end, there were over 200 tasks, and this says 441. I think the most latest thing I saw before people were citing it was 444 co authors, and I'm in there somewhere. Yes. Um, Small wins add up. So I'm glad that even though there are many hundreds of people that were given co authorship credit, it's pretty cool to be part of a paper like this that gets used and cited around the world, and it sort of disrupts this academic slash high level research group monoculture. In web development, we used to have a lot of different ways to do on ramps. Like someone can do a pull request to a major library, and that's pretty cool. They'll talk about what they did. So I hope that this kind of open source, not just the code's online somewhere, but this open source methodology, this open source system of someone from out of nowhere can submit a good contribution and become part of the team. I hope that comes to machine learning as well. I guess you could also argue that the monoculture was not super disrupted. I mean, they have a list somewhere of all of the people and institutions and tasks, and a great deal of them you'll see come from Google or Stanford or other research and university things. But it's definitely very interesting to have this as an open thing nonetheless. The timeline of this is a little bit confusing because you're only starting to see papers around now that are citing and using Big Bench. first started talking about this, well, I first started hearing about it. I'm sure somebody internally knows more. The sort of public announcement of this started in March of 2021. There were two types of tasks that you could submit, one of them being sequence to sequence, one of them being multiple choice. You've all done multiple choice quizzes at school. Sequence to sequence is more like a translation task where I give you a sentence and you return with a sentence rather than having the sentences written out for you. And then that's graded based on usually a derivative of the blue metric of comparing the goal sentence to your output sentence. They also created this do not index marker, which is a very long string that's sort of placed into our source code so that that source code does not get searched by models that are then evaluated on the task, because then they would know all of the answers ahead of time. There's some confusion around this where people thought, oh, I'm going to paste this into my website or blog or code and it's not going to be read by AIs. That's only for like people who are voluntarily creating their models to be tested on this benchmark. So there's no reason to believe that it's going to work like a robots.txt, even to prevent Google from indexing it and putting into very large models. It's more just a convention to make sure we weren't kidding ourselves when we created these tests. June 2021 was the initial deadline for contributions. I think it might have gotten postponed a little bit. And while that was happening, I submitted an idea pretty early on and was asked to review 3 other pull requests. So it was a mini peer review process, which is rather interesting. By September, they said, okay, here's the benchmarks that are going to go into our overall paper, recording our info and interest in writing or editing. I used an email, which I ended up not having very much access to after that, so I didn't really continue working on it. So I went sort of like a dark period where I didn't know what they were doing with it exactly. March or April of this year, 2022, there were some DeepMind/Google papers that were including their results on Big Bench tasks, which was rather interesting. And then in June 2022 is when the preprint was officially released on arXiv. And so that's interesting that about like 4 months later is when we're starting to see a lot of people citing it in their own work. The general idea behind Big Bench was that they wanted to show that these very large language models, whether you're looking at language or code, were a way to show the reason to have a very large model. So the first of these line charts here, the first one shows that a lot of tasks improved linearly with the size of the model, but then there's also a second group of tasks where it didn't seem like you were making any progress until suddenly when you had a model with many hundreds of billions of parameters that you started to get some results. And then the final task were things that the models never really got very good at. One of them being Persian idioms, which makes sense because the model was likely trained on a very large English language data set. They have a few other items there which the models did not do well on. They have a mention in the paper of one of the tasks that I submitted. I'll talk about that a little bit later, because they wanted to highlight tasks that were being encouraged and accepted, but due to using different languages, were not really doing well in the initial Big Bench model survey. So yeah, the task that I submitted, the first one was disambiguation questions, or it's gone to QA now, I think. But basically, I went to 2 existing benchmarks, Winnow Bias and Winnow Gender, and I wanted to come up with examples where, and I added a few of my own examples, where you're adding a person's name and you say her office, and the antecedent of the pronoun is ambiguous. So in a sequence-to-sequence model, they would identify this is ambiguous and then say, here's a question I could ask to straighten that out. Or they could write unambiguous if it's completely straightforward. In the peer review process, someone felt strongly that this structure was very difficult for the model to figure out, especially just looking at one or two examples, which makes sense. So it created a multiple choice version of that. Um, to be honest, that feels a little bit less novel. You kind of look at it and you're saying, okay, I kind of get what you're doing there. Uh, so I don't know. Interesting discussion that I just said, you know what? Okay, let's make it a multiple choice project. And I think as a result, there are some people who collect bias metrics on Big Bench and they aren't so interested in this. It doesn't seem so novel. But that's why it is what it is. The Which Wiki Edit project is something I'm interested in making into a continual benchmark where you look at some articles on Wikipedia, recent edits, and once you get those edits, you try to match them to the edit message. So in English, you can imagine if someone's written a very long additional section about, let's say, someone having a new baby, then the new section would have some information about, oh, they gave birth and blah, blah, blah. And then the edit message would be, oh, new baby, and it sort of link those. And what's good about using Wikipedia is we get these changes, we get these diffs, and they exist in every language version of Wikipedia. So I was hopeful for this as a multilingual, continual benchmark. Um, I have some scripts somewhere. I haven't published it anywhere, but I just ran it one time and said, they can run this in the future if they feel like language models are going to know what happened on Wikipedia so recently. But it looks like the models don't do very well on it, so you don't hear about this task as much. Some negatives of the process: there were, I would say, less conventional NLP tasks. So someone has an example with ASCII art, and if you're just looking at that, if you know how language models tokenize text, it's not looking at it in the way that you or I would look at a block of ASCII text. So it has no idea what's going on. Alphabetical order is something you can do very easily with Python, but might be rather difficult for a language model to figure out how to do it, because they have to have everything in some sort of memory or something like that. Then non-English tasks, as I mentioned, are really important to have out on the web in the NLP space, and they haven't been discouraged by Big Bench, but they haven't been really used so much by Big Bench because people aren't, or I should say the models aren't doing very well on them because of the overwhelming amount of English language data. As a reviewer, it was interesting to be in this role. I wanted to know sort of the overall vibe, if I was supposed to kind of nitpick and find problems and look through the examples, or was I supposed to guide them towards acceptance? If it was something that was somewhat passable, I felt like we should accept it. But I could understand other people saying, this looks pretty similar to an existing benchmark. What is it doing here? So we sort of had to hash that out in the GitHub issues and pull request comments. I was asked to review a Swedish-German proverbs task where, I don't know either language, so I couldn't make head or tail of that. But we did accept it. And then it was odd that I reviewed, I think in the end, 5, and then there were only 2 people who reviewed mine. So maybe only some people were selected to be reviewers, or it's a little unclear there. One of the tasks was a depression symptom task, which checked out in terms of the way it was organized, but then people raised issues about the license and whether people's messages in there revealed some personal information. And I think they made the right decision erring on the side of privacy and not including it in the benchmark. Also, something that sort of comes out of the general community feeling at the time is in early 21, there was a huge interest in this 0-shot, 1-shot, and few-shot tasks. I mentioned earlier that my ambiguous, unambiguous, or sequence-to-sequence task was rejected in part because of this, because people wanted the models to have a fighting chance at working from just 1 or 2 examples. And from a commercial perspective and from like an end user perspective, I do understand that you want to evaluate the models based on, if someone logs in and says, I need a language model to come down and do something with my text or my spreadsheet, that it'll understand those instructions rather than needing many thousands of examples. So that's what people were really interested in, a year and a half ago, in the same way that the way I'm talking about this now, people are really interested in projects that are multimodal with like Stable Diffusion or DALL-E. So this was sort of the vibe that people had at the time, just using text, focusing a lot on something that could be explained to the model in a zero shot or one shot context. I think it's important to realize how important this idea of one shot, few shot tasks, because the paper that announced GPT-3, for example, is not called, we made GPT-3, it's awesome. Instead, it says language models are few shot learners, because that was so important. Instead of having hundreds or thousands of examples, you could sort of explain something to a language model and it would perform really well on conventional NLP tasks. This isn't the same thing as one hot. That's like a tabular data thing that we don't do anymore. And I also wanted to shout out that a zero shot example is, instead of showing any examples at all, you just write a description of what you want to do. So the example I wrote here is, if you imagine your customer service for an app like Blue Apron, you just give the instructions of when you issue a refund or when you don't. So if a box never arrived, you would issue a refund. If someone says they cooked something and they burnt it and they didn't like it, then probably you wouldn't issue a refund, something like that. And then the chatbot or whatever would be able to either route these future customer information to the right place, or sort of respond with these sort of simple instructions as it's explained to them. I mentioned before that DeepMind and Google were the first ones to announce that they had results on the Big Bench task, even before the paper had been released. So this was in April, the PaLM language model showing their results with zero shot, few shot examples compared to other models. Notice that the average human got about a 50 score, so there's improvement by the PaLM 5-shot model over that. But the best human, it says, got like almost a 90 score on this, which makes me wonder if they were multilingual or there's something that was going on there where they're paying a lot of close attention to the instructions. But there's a very wide range there in human performance, and these language models were only just cracking over the average human performance. Gopher and Chinchilla, with this paper, they had some different theories about what makes language models good. Could you get GPT quality or Gopher quality performance with a smaller language model? And so they have some different logic here about the initial corpus size, how long it's trained, the size of the model itself. And this one I pointed out because so DeepMind did something where they said they could improve the performance of so they picked some tasks which weren't working very well on Big Bench for language models, and they said, what if we added explanations? So it's a few shot example, but they add an explanation of why that's the answer. And they have some different interesting controls for this, different examples from other tasks or explanations that don't have anything to do with the task. And it does appear that giving an explanation in the prompt does help a lot. And disambiguation questions was one of the tasks that they selected here, so I felt pretty special about that. So in the end, this is a new benchmark. Google and DeepMind adopting this in papers and discussing it so in depth shows some confidence, and then it's starting to roll out to the research community. I'm sure there's, of the 400 plus authors, a lot of people who would be interested in helping that spread to other papers and things. It's also one thing that this adds here is it's okay to train on a subset of the tasks. So sometimes people are picking ones that are like closely related to something they're studying, or they're removing tasks that are not English based, or anything like that. It's okay to not to say instead of 200 evaluation tests, you're going to pick the ones that are relevant to your paper. I mentioned earlier that it is coming out of that generation of language models, NLP, and I do like that this benchmark that's so public could be open to the less established contributors. I hope we see a lot of this in the future. In fact, you can still submit pull requests to Big Bench if you're curious about that. I haven't seen whether they're going to do another round of this or like an image-based one, but there's a lot of different ways that people are getting involved. So that's it.